Okay, so today we're talking about functions, adding them, subtracting them, multiplying them, dividing them, and even doing functions of functions. Thank you. You got your sheet? Did you already hand it to me and I'm losing my mind? All right, thank you. Okay, so to start with, I'd like you to write down these two functions at the top of your paper. F of x equals x squared, and g of x, square root of x plus 5. All right. First of all, we need to graph it to remember how its domain's going to look. So to start with, a plain old parabola starts there and then goes over 1 and up 1, over this way and up 1, over 2, up 4, over 2, up 4. Remember? Okay. And how about a square root function? You remember how it generally looks like that? And then this one would be moved which way? Left 5 because of that. Okay, so then I grab this thing and I move it to the left 5. 1, 2, 3, 4, 5. Okay, now I'm going to re-graph that, or at least I'm going to put some dots on it that are like sure thing points. Over 1, up 1, over 4, up 2 should be on it, and over 5, 6, 7, 8, 9, and up 1, 2, 3. That was actually pretty close. Okay, so now it's been graphed. Now, in the directions up beneath it, it says domain, just a number line. Do you remember how on your domains I was encouraging you to write your domains like this, and if there was some point that didn't work, you'd like have an empty spot, and then you go like this. That way you'd remember to say that it was like negative infinity to 5, and it doesn't work at 5, union with 5 to infinity. That's the number line part, right? That's the part that I want you to do right now, just the number line part for these two. Draw me a number line for this one. Draw me a number line for this one, where it works. Remember, domain is left, right. Pause while you do that. Okay, so I drew in some arrows on my graph just to make it clearer which ways they go. The domain on this one on the left is from negative infinity to positive infinity. In other words, everything works. Doesn't ever stop, doesn't ever have a hole in it, doesn't ever have a asymptote stopping it, so it's from negative infinity to positive infinity. The domain on the other one is not unlimited. At negative 5, there's an important moment. Does it still work at negative 5? Yes, because if you stick in a negative 5 right here, it's square root of 0, which is okay. It's 0. It's not a problem. So it works there. And it works everywhere to the right of that. But it doesn't work on big negatives because you'll have negatives under the square root. So there's my domain of the first of the trickier graph. Why do we need to know these domains again? Because today you're going to be blending the functions, like you're going to say f of x plus g of x. And then that means you need to blend the domains. The domain for the answer is going to be a mix of this domain and that domain. And when you mix them, you pick the places where they would overlap each other. I'll show you that again in a minute. All right, for right now, here's the booky kind of language on how you do these problems. These are sum, which means add, subtract, multiply, and divide functions. Let f and g be two functions with intersecting domains. That means when you do graph the one function, its domain, and you look at the domain of the other function, that they overlap some. Let's say we had this, where it's bigger than 0. An empty spot there. Then wherever they overlap, it's going to be the domain of the new combined function. All right. Now it shows you the sum one. Sum means add. So you just take the two functions and you add them together. Done. You just write the function and write the other function, you add them together. It's really easy to actually do these problems. It's the domains that are trickier. Difference, you just take the two functions and subtract them. Product, you just multiply the two functions. And quotient, you just divide them and make sure you put the whatever's on top here needs to be on top over here, because otherwise dividing them backwards would be bad. Okay, in each case, the domain of the new function consists of all the numbers that belong to both the domain of f and the domain of g. So that's, again, the places where they overlap. All right, so I'm going to show you some examples here. To start with, these two functions that we graphed before. If I want to do f of x plus g of x, it's as simple as this. What's f of x? So I put an x squared right there. What's g of x? Square root of x plus 5. Put it right there. Would be x plus 5. And my answer is that plus that. Can I actually add them? Nope. So I leave them. I'm done. That's all I got to do. It is that simple. How about f of x minus g of x? Well, I take f of x, which is x squared, and I subtract g of x, which is square root of x minus 5. So it's just that minus that. That's it. What's this new function? This is a bigger, nastier looking function. The new function has a name, and it's called f of x plus g of x, but they usually write it, instead of writing this, they don't write that for its name. They call it f plus g of x. Sorry about the crackling. Gotta figure out how to stop that. Right now, I'm just gonna have to live with it. Okay, so my new function for subtract, f minus g of x. I'll put parentheses around that sometimes. My new name for the multiply function. Well, what is the answer? The answer is to take x squared plus that, square root of x plus 5, and multiply them together. And I can't really do anything more than I already have. This is not an equation. I can like do stuff to both sides or anything. I'm just done. That's it. But it needs a name. And its name is not f times g. It's just fg of x. Doesn't that sort of look like they're being times? They're right next to each other. And for the divide function, I just divide them. I figure out what f of x is, which was x squared, and divide it by g of x, which is square root of x plus 5. And there's my function. And it needs a name, and you can't use that for the name. So what the name is f over g of x. All right. That's the basics of add, subtract, multiply, and divide. And they really are that simple. You just add the two things, or you subtract them, or you multiply them, or you divide them. But the domain and range is the more tricky part. I'm going to draw a picture of this domain. I want you to also. And underneath it, I want you to draw the other one's domain. Go ahead, shade it in. Make two lines right on top of each other. You need to learn how to put them right over the top of each other, because that really helps you to see where they share domain, things that work. So negative 5 does work, so I fill that in, and it works when numbers are positive. Do you see how these two overlap from there over? So the domain of my new hybrid function, a hybrid is a mix of the two, is from negative 5 to infinity. Does it work at negative 5? Yes, it does. They both work at negative 5 here, and it works here. So it works at negative 5, goes all the way to infinity. Here's my domain. And by the way, that's the domain for all three of these. You don't have to refigure it out, because add, subtract, and multiply, you do the same exact thing to find their domain. Whether it's f of x plus g of x, or f of x minus g of x, or f of x times g of x, you do the same thing for the domain. I'd love to fix this crackly noise, but I can't, so try to ignore it. Okay, now on the divide one, that's where it really it is different. And here's why it's different, and I hope this makes sense to you. This is the only one that has a denominator. You know, this one didn't have a denominator, neither did this one, neither did this one. This is the only one where there's a denominator. What do we have that's special about domains that we're not supposed to let the denominator do what? Not supposed to let it equal 0. So g of x can't be 0. I got to remember that when I'm doing this domain. It's like the others. It's the same thing as the others, but it has one more restriction on top of it, and that is that it can't be -5. So it's almost like I should do the first, for doing multiply, I should say, here are the things that it has to follow. The first function, f of x function, anything works. The g of x function, things that are bigger than or equal to -5 work. But there's a last thing that you have to think about in your dividing ones, and it's the third thing, and that's that the denominator of g of x cannot equal 0. So if I look at this function, g of x function, which is right here, what would ever make that 0? If x was -5. So it's not supposed to ever be 0, so I can't ever let it be -5. So I can say its only new restriction is x cannot equal -5. That means that this has got to be an open hole here instead of a closed one. So that means, where's my red marker? That my final answer is not -5 to infinity with a bracket. It's a parenthesis. It's not a big difference between these two. But on this one, -5 can't work, so I have to put a parenthesis around it. I know some of you are going to get, there's going to be like a 3-part question, just like this. You know, find this, find that, and find their domains. And you're going to do everything right, except you're going to forget on this last one. When it's divide, you got to not let this be 0. And then you'll get that whole problem wrong. And since there's only 8 questions on every test, then you now have gotten another one wrong, and it's probably going to knock you from an A to a B. Okay, so watch out. Remember this one like little exception you got to be careful of. Okay, and we're really famous for making the test include some of those things. All right, now you remember before I was saying that in your notes, it'd be smart anytime I make a big point of something to put a star next to that thing. Did I just make a big point about something? So you should therefore put a star next to it in your notes, because then later, there's later you and there's now you. Now you might feel a little too lazy to pick up your pencil and put a star next to it. But later you would really appreciate it if now you would take a second and make a little star. Because later you that's looking through your notes is going to be like, oh yes, I have stars by the important things that he said were really important. Okay, so be nice to later you. All right. One last thing you need to learn how to do, and let's wade through this together. It's not that hard, just one different kind of problem. Here's an f of x, here's a g of x. And it wants us to find FOG of 3. That does not mean f times g. That little o means f of g of 3. And then a separate question, g of f of -2. I bet you this will make more sense to you if I wrote it this way. Do you get that I could do f of 2? It'd be really easy. I just stick 2 into the f function, right? But what if I did g of f of 2? It really wouldn't be that bad if I start by figuring out f of 2. Do you get what I'm saying? All right, so what is this asking me? This is asking me for f of g of 3 is how you say that. So I'm going to write it that way, f of g of 3. So what do I start doing? G of 3. Once I figure out g of 3, I'll have a number, and I'll put it here. All right, so what's g of 3? Well, I find this function, I stick a 3 into it. And what do I get? 3 plus 1 is 4. So g of 3 is equal to 4. Now I do f of 4. Because see, g of 3 is 4. I just drop it in there. Now f of 4. Well, now I go over to the f function, and I put in a 4. And that means 2 times 4 is 8 minus 3, which is 5. So f of 4 is 5. And then done. I want you to see if you can figure out g of f of -2 over here. Try that one. All right, what you should have written by now is g of f of negative 2. And how do you start? Oops, I need an extra parenthesis there. I start with this, f of negative 2. So I stick a negative 2 in the f function right there. And I get negative 4 minus 3, which makes negative 7. Then you have g of negative 7. And I go to the g function. And I drop in a negative 7. And I have g of negative 7 equals negative 7 plus 1. Negative 7 plus 1 is negative 6. Raise your hand if you had negative 6. All right, good. Most you. All right. Here's one more. Figure out f of g of 4, which is the same thing as f of g of 4. I like writing it this way better. You need to understand it's the same thing as that, though, as I think we write the tests with that. Okay, so I would have started this way, and then I would have figured out g of 4. So I go g of 4 is 4 plus 5, which we square root of 9, which would be 3. So that part right there is 3. F of 3 then is my new problem. I stick in a 3 into this function, and I get 3 squared, which is 9. Raise your hand if you had 9. Okay, good. Now we're going to do the next step on this tomorrow, which is where you take these functions and make them significantly more complicated by using not just numbers, like figuring out f of g of 4, but we might be figuring out f of g of p. And it's not that much harder, but it definitely adds some difficulty to do compositional functions, it's called. And it's more than just that, too. But anyway, I think we've learned enough for that we need to know for today. So here's our homework. It's page 124, 1 through 8, and 11 through 14. And those of you that need to take that test tonight, make sure you study for it and get it over with tomorrow, either tonight or after school or tomorrow morning, so that we can talk those over in class.